Hello, ladies and gentlemen. Welcome back. We are continuing chapter 5.1, day 2. Now, I have to emphasize that it's going to be so important that you read what's in the book. Again, those are my expectations that you are reading the chapters, especially the key words and all of that stuff and the examples. Okay, please, 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 please be looking at all of that. So I'm going to take you through some things in this video that I'm going to emphasize, and please pay attention to those. All right, here we go. So on page 332, it talks about bias. Folks, we don't want bias in our data. This is a huge, huge, huge factor when you're doing an experimental design. You want to avoid bias. So the sampling method is biased if it is systematically favors certain outcomes. All right. Now, what we want to do, ladies and gentlemen, is we want a simple random sample. Okay, now we abbreviate that SRS. So if you hear me say SRS in the future, that means simple random sample. A simple random sample of size n consists of n individuals from the population chosen in such a way that every set of n individuals has an equal chance to be the sample actually selected. Okay, so this gives everybody an equal chance. Now, sometimes simple random samples are not the best choice. We'll talk about those later in chapter 5.2, block designs and things like that. But simple random sample, we're going to stick with that for the moment. Now, on page 335, it talks about random digits. A table of random digits is a long string of digits 0 through 9, with these two properties. Each entry in the table is equally likely to be any of the 10 digits, 0 through 9. The entries are independent of each other. That is, knowledge of one part of the table gives no information about another part. Now, there is a random digit table in the back of your book. Find it. Okay, random digit table in the back of your book, which is the same random digit table that I'm going to go over with you here. I believe it matches. So I'm going to show you the random digit table, and I'm going to do random digits on the calculator. Now, let me pull in Schoology quick. I did put the random digit table right underneath this video. Okay, it is right here, ladies and gentlemen, and you can find one in the back of your book. But if you would rather have a printed version of the random digit table, please feel free. Okay, this is what it looks like. All right, and I believe the one in the back of the book is the exact same random digit table, and this is the one they use on the AP test. Okay, all right, so that is there for you to look at, and I'm going to show you how you can do some random digits on the calculator. All right, so first of all, we're going to look at a situation, and I'm going to show you how to do it with the table first. All right. Whoops, that's the wrong one. I'll get to that in a little bit. All right, so when you choose a simple random sample, there are 4 steps to follow. Okay, write these down and memorize them. 1, label. Assign a numerical table to every individual in the population. 2, table. Use table B to select table labels at random. Okay. 3, have a stopping rule. Indicate when you should stop sampling. Well, it's usually after you've picked however many you need, right? 4, identify the sample. Use labels to identify subjects selected to be the sample. All right, let's look at an example, folks. A university financial aid office wants to know how much it can expect students to earn from summer employment. This information will be used to set the levels of financial aid. The population contains 3,478 students who have completed at least 1 year of study but have not yet graduated. A questionnaire will be sent to a simple random sample of 100 of these students drawn from an alphabetized list. Interesting. Okay, describe how you will label the students in order to select the sample. Okay, folks, well, there are, let me switch colors here so it shows up a little bit better. There are 3, Okay, hold on. I'll have to get that back. Be back with you in a second. All right, ladies and gentlemen, I believe I have that fixed. Here we go. So again, there are 3,478. That is the population. And we're going to pick a simple random sample of 100 of these students. So describe how you will label the students in order to select the sample. Well, folks, there are 3,478. That's a 4-digit number. So that means what we're going to do is we're going to label every student with a number from, okay, now get this, you got to go 0, 0, 0, 1 to 3, 4, 7, 8. Everybody has to have a 4-digit label. You can't give the first student a 1-digit label. That doesn't work when you're doing using the random digit table. Okay, so 0, 0, 0, 1 through 3, 4, 7, 8. You label with everybody gets a number. Okay, now you could then put the numbers in a hat. And then we're going to pick out 100 of them. All right, so use the table begin at line 105 to select the first 5 students in the sample. All right, here we go. So I'm going to go to line 105. All right, here's line 105. Now I have to go every 4 digits, ladies and gentlemen. So the first 4 digits are 9559. I have to skip those because that doesn't represent a student because there's only 3,478 students. The next 4 digits are 2940. Oh, so student 2,940, that will be one of them. So that student is selected at random. Okay, hopefully I don't mess up as I'm doing this. So 2940. Okay, the next student is going to be 0769. Yes, that is a student, 0769. All right, let me go back to here. 0769. There's student number 2. All right, let's go back. Now the next 4 digits are 9719. Nope, that's not a student. I have to skip that. The next one is 1481. Oh, 1481. So that student is selected. Sorry about that. It didn't disappear this time. I just clicked the wrong thing. 1481. Okay, so keep going. The next student. The next one, okay, well, the next one is 6077. Nope, that's not a student. The next one is 9537. Nope, that's not a student. The next one is 9117. Nope, that's not a student. Hopefully, again, I'm not messing up here. Looks like the next one is 2975. Okay, 2975. 2975. And then you have to pick one more. Okay, so again, you have to keep going. 2975. Okay, the next one is 9333. Okay, that's not a student. Okay, then you go to the next line. 6841. Nope. 7350. Nope. Looks like 1315. Student 1315. Okay, again, hopefully I didn't mess up anywhere along there. Sorry, I keep pushing the wrong button. And then did I say 1315 on that one? All right, so those are the 5 students that are going to be selected. Now, on the calculator, use the calculator to select the first 5 students in a sample. Well, the calculator is a whole different ballgame, folks, okay? So on the calculator, here we go. So let's go to the calculator. Okay, you will find the random integer stuff in math. So hit your math button. And then you go to probability, because this is all in probability. So I'm going to show you with number 1, the rand, and then number 5, the rand int, okay, which stands for random integer. Now, just a warning, folks. Okay, hit the clear button. The calculator technically is not random. Okay, it has an algorithm in there. Okay, so usually what I have students do, okay, and this is what I would like you to do, is I would like you to use your birth month and your birthday. Okay, so you type those in first. So like mine is March 31st. Okay, I was born on March 31st. I was almost an April Fool's birthday. Okay, so I type that number in. Okay, what we're going to do is we're going to seed the calculator. Okay, so if everybody seeds it in a different spot, unless you have the exact same birthday, you're going to get different results. That's good. We want randomness. Okay, so now you hit the store button, STO, on the left side above the on. Now go to math, and then go to probability, and pick number 1, rand, and then hit enter. So what I have done is I have seeded the calculator to start in a certain spot on in its random digits. Okay, like on the random digit table, I'm telling you where to start. Okay, so I'm telling you that's where I'm starting. Okay, you can start where your birth month and your birthday. So again, let me repeat that. So type your birth month and birthday, then hit store, math, probability, number 1. Okay, now we're going to use the calculator to pick out the 5 students. So we're going to go back to math. Okay, well, first let's do this. Let's clear. Go back to math, go back to probability. Okay, pick number 5. Pick number 5. Okay, number 5. Now, with the calculator, you don't have to worry about 5 digits. You could have them labeled number 1 through 3,478. So this is what you do. Okay, there's several ways you can do this. You can go 1, that means student 1, comma, to student 3,478. Okay, let me just double check that it's that many. Okay, my mind sometimes, yep, 3,478. Okay, now you could close it with the right parentheses and you could hit enter, and there's the first student. Now, the nice thing with this is you don't have to worry about students that don't exist, because you're only limiting it to the 3,478. So it's going to randomly pick a number from 1 to 3,478. And then if you hit enter again, it will randomly pick another number, and then another number, and so on. Now, the cool thing also is I could have it pick all 5 at once. Now, the question is, what if the calculator repeats a student? Well, you ignore it. You skip that and go to the next one. Same thing on the random digit table. What if you have the same student show up twice? You skip it. You go to the next student. All right, so you could, ladies and gentlemen, actually have the calculator. So again, math, probability, number 5. You can have it select all 5 at once. So 1, comma, 3,478, comma, and then put a 5, close it, and it will randomly pick those 5 students all at once. The only thing is they don't all show up on the screen, because you have to then use your right arrow key and you can see the other students. So you could either do it individually like I did at the beginning, or you could have it select all 5 of them at once. Okay, sometimes it's better just to select one at a time and mark them down. All right, so if you didn't get any of that, please rewind and rewatch that. All right, let's keep going. All right, so if you were in class, I love this activity. Oh, I love this activity, but we can't do this. But I'm going to show you. Okay, scenario. Results from polls and other statistical studies reported in a newspaper or magazine often emphasize that samples were randomly selected. Again, huge, very important. Why the emphasis on randomization? Couldn't a good investigator do better by carefully choosing respondents to a poll so that various interest groups were represented? Perhaps, but samples selected without objective randomization tend to favor, ooh, that's huge. Okay, I'm going to underline that. Okay, perhaps, but samples selected without objective randomization tend to favor one part of the population over the other. In other words, there's bias. For example, polls conducted by sports writers tend to favor the opinion of sports fans. This leaning toward one side of an issue is called sampling bias. In the long run, random samples seem to do a good job of producing samples that are fairly representative of the population. Now, if we were in class, we'd do this little sampling activity. Okay? How do random samples compare to subjective or judgmental samples in the terms of sampling bias? Okay, so I do have these on underneath the video. Okay, here's the random rectangle scenario. Okay, I don't need to have that pull up, and then there's a random rectangle sheet. So if we were in class, ladies and gentlemen, what I would do is I would hand out this random digit or this random rectangles to you, and you would not be able to look at it. It would be turned upside down. Okay, you can see there's 100 objects in there with various little squares, okay, or areas. For example, like number 7 has 1, 2, 3, 4, it has 12 squares. So the area of number 7 is 12. The area of number 8 is 1. The area of number 14 is 4, and so on, okay? And this is what we would end up doing, okay? How do random samples compare to subjective samplings in terms of sampling bias? So what I would have you do is first, we would do 2 judgmental guesses. Okay, well, first is a judgmental guess. So what I would have you do is I would have you flip over the random rectangles, and I would just say, okay, guess what you think the average area is. Out of all 100 of those, what do you think the average area is? And I'd only let you look at it for maybe 5 seconds, okay? And then I would have you write those down. What was your guess at the area? Okay, what do you think the average area is? Okay, then after we did that and we figured out the class average and we did all of that, your average, we would then do a judgmental sample. Okay, so what I would do there is I would say, okay, ladies and gentlemen, flip over your paper and you pick any 5 that you think would be good ones to help figure out the average. So you'd maybe get 10 seconds to do that. You would pick out 5 of them, maybe 15 seconds. You'd pick out 5 of them and then find the average of that one, of those 5, okay? And then what I would have you do is I'd have you use the random digit table or the calculator, and then I'd say, okay, using your random digit table or your calculator, randomly pick 5 of them. So you would like have the calculator pick 1 to 100, so it'd pick 5 of them, and then you would find the average for those. I've been doing this pretty much every year since I've been teaching AP Stats, and it works every time. Ladies and gentlemen, the judgmental guess and the judgmental sample are way off. Okay, they're way off. And we have a small class, so it probably would be even more off. When you have a bigger class, it works better. And then we will do then we will compare it to the random sample. And guess what? It would actually be very, very close. The actual answers for this one turns out to be the average turns out to be 7.42 for the area, 7.42 squares. The median turns out to be 6, and the standard deviation turns out to be 5.228. Okay, that's doing it with a random sample. It always works out so close. I wish we could do it, but we can't. But hopefully that gives you an idea of why sampling is important. All right, so let's continue. I don't want this video to be super, super duper long. All right. So, folks, then I would end this part of the lesson with, in other words, randomization reduces sampling bias. Okay? Again, randomization reduces sampling bias. All right, continuing. All right, so going back, page 339, a probability sample. A probability sample is a sample chosen by chance. We must know the samples are possible and what chance or probability each possible sample has. We'll talk more about this when we get into the probability chapter, which is the next one. All right, so I'm not going to read through these, but again, I have to emphasize you need to go through these in your book. So maybe pause this and look at this example. Okay, page 339. Stratified random sample. So these are different ways of sampling. They're not specifically simple random sample, but they incorporate it. Stratified, and you have to know these. They love these types of questions on the AP test, folks. Okay, so you need to know the differences. So maybe make note cards of these or something. Stratified random sample. To select a stratified random sample, you first are going to divide the population into groups of individuals called strata that are similar in some way that is important to the response. For example, a common one is male, female. Stratify them into male groups, female groups, and then randomly select from the male group and then the female group. Then choose the simple random sample from each stratum and combine these simple random samples to form a full sample. Okay, so see example 5.6. A cluster sample. See example 5.7, please. Cluster sampling divides the population into groups or clusters. Some of these clusters are randomly selected. Then all individuals in the chosen cluster are selected to be in the sample. Okay, so again, all the individuals, this is a big difference, all the individuals in the chosen clusters are selected to be in the sample. For example, we could, in the high school, we could cluster by classroom, right? So then we could randomly select a classroom, and then everybody in that classroom is going to be selected for whatever we're doing. Okay. Multi-stage. Okay, multi-stage found on page 340. Okay, so I'm going to let you read through that. Okay, read through the multi-stage. All right. Now let me make this a little bit smaller. For some reason it's not showing up on my screen very well. Well, that didn't do it either. Let's go with best fit. Well, that's way too small. Let's go with height. Well, anyway. All right, so it's not working out for me, folks. There we go. That's a little bit better. So multi-stage sampling, page 334. Stage 1. Okay, here's an example. Stage 2, stage 3. So there are stages to a multi-stage sample, obviously. You read through that, please. You're all capable of doing that. All right, page 343, undercoverage and non-response. Ooh, that's huge, folks. Undercoverage occurs when some groups in the population are left out of the process of choosing the sample. It's pretty obvious, undercoverage. Non-response occurs when individuals chosen from the sample can't be contacted or do not cooperate. Okay, I've been getting a lot of phone calls and I don't know, sometimes I've answered a few of them, they're opinion polls, and I don't answer them. I'm like, nope, hang up. Okay, I don't do it. I'm a non-response person. I'm a non-response person. Please see example 5.8 and 5.9 on that. Okay, so look at those examples. Okay, you read through them. Okay, here's a cartoon with response bias. Example 5.10. Okay, so read through that. All right, moving on. Page 346, wording of questions. Okay, wording of questions. Example 511. It is, if you word something a certain way, it can favor a certain response. So the wording of a question is the most important influence on the answers given to a sample survey. Confusing or leading questions can introduce strong bias, ladies and gentlemen. So if you are working with the newspaper with Mr. Pauly, make sure that if you're going to do that, you have good questions. And even minor changes in wording can change a survey outcome. Here are two examples. Okay, so again, look at those two examples, example 11 and example 12. Okay, please look through that. All right. And let's see, I've got sampling frame. Okay, they talk about sampling frame right here, problem 15. So please read about the sampling frame by number 15. And I believe that is it for this video. So a lot of reading to do in your book with those different examples. And make sure, ladies and gentlemen, you look at the cautions. Okay, make sure you look at the cautions. Here's a very important one. We can improve our results by knowing that larger random samples give more accurate results than smaller samples. Okay, that should be common sense. Larger random samples give more accurate results than smaller samples. So make sure you are finding all of those cautions as you're reading through the book. All right, I'm going to go ahead and take a minute break here, and then I'm going to make the next video for chapter 5.2. See you soon.